Okay, so hyperbolas is what we're looking at today. So when you're talking about hyperbolas, okay, they're going to look a lot like the ellipse as far as equation goes. Obviously, this doesn't really look the same. Although, if you look, it's really just two pieces of an ellipse that have been turned backwards. Okay, if you think about half an ellipse, here and here, you just turn them backwards. And that turning backwards happens because on an ellipse, we have a plus sign right here, but on the hyperbola, we now have a minus sign. Everything else is the same. I've got the x minus h squared over a squared, y minus k squared over b squared, all equal to 1. So again, the only thing different is that the ellipse would have a plus sign there, and a hyperbola has a minus. So that's how you can determine the difference between the ellipse and the hyperbola. The circle, of course, is the other one we've covered, and it's got a plus sign in between as well. But it either has no denominators, or those denominators would be exactly the same. So if you end up with the exact same denominators, that would make this thing a circle. Now, the parts to these things is pretty similar. We still have vertex, okay, or vertices rather. So these are my two vertex. Vertex here and a vertex here. Okay, and the little circles that we have out here are the foci, okay, or a focus, foci, focus, okay, one is plural, one is singular, that's how that goes. A new word for you is the transverse axis. Now, the transverse axis is going to go through the center here, which, by the way, this is the center, okay, and this would be what we call the transverse axis. Okay, the transverse axis connects the two vertex, and that actually says it down here if you look at your bottom information here. The transverse axis runs from vertex to vertex, okay, and if I wanted to know the length on your homework, it says to identify the transverse axis. Well, they want you to identify the length of the transverse axis. Well, from center to the vertex is still our A value, just like it always has been, okay, so just like in the ellipse, it is from center to vertex is our A value, which means that the transverse axis is 2A. So once you have your A value, if my A value was 3, if it was 3 units from here to here, then my transverse axis would be 6, because there's 2 of them. So there's 3 and 3. So you would just write down 6 for the transverse axis. Okay, so vertex to vertex. Now we also have the distance from the center all the way out to that focal point is C, all the way out to the focus, more proper, to the foci is going to be your C values, okay, just like it has been. Now, I will say this, though, is that typically our focus in the ellipse is inside, okay, and now we're still inside the hyperbola, but now it's outside of that little box, and we are going to talk about how we make that box. We also have these 2 points we use, although we no longer identify them because it's not technically part of our graph at all. However, I need these 2 dots in order to build my box. So I'm going to continue to call those co-vertices, although they technically are not even part of this graph anymore, so they aren't really there. So we're going to just keep calling them co-vertices just to kind of stay consistent. Okay, so these do have a distance, though, which is B. Okay, so from center out to our co-vertices, so to speak, is our B value. All right, and now 2 new pieces are the asymptotes. Okay, the asymptotes. So these lines that are dotted here are called asymptotes. Okay, and we'll talk about what those are in just a minute, but those are new pieces, and I'll show you how to get them, which really we're going to have to write an equation for them. So we will get there shortly. Alright, so that's all my new pieces to my hyperbola. I can have 2 different types of hyperbolas. One is going to go horizontally and one will go vertically. So let's talk about that. Now, when you look here, okay, the horizontal transverse axis, so meaning this thing goes across, so this thing is horizontally, which opens left and right, meaning that it will go this direction. Here's how you open left and right. And a lot of people think it's easier because it's horizontal. The shape itself kind of makes an H looking thing there. Okay, so if that helps you remember that horizontally opens left and right, then fantastic. Okay, well, the one that opens left and right has an X in front, and the one that has a Y in front is our vertical one. So this is where the biggest difference between the ellipse and the hyperbola comes into play. Okay, with the ellipse, and if you don't remember, you can go back and watch the video, but with the ellipse, the most important part is which one has the largest denominator. Okay, so to determine direction, you find the biggest denominator for the ellipse. To determine your vertices, you look at the biggest denominator. To find your A, you look at the biggest denominator. On the hyperbola, okay, what really matters is what comes first. Okay, and if you need to like star that or something, hyperbola is what comes first. That is what's going to determine our direction, our vertices, our A value, okay? Because notice here, I've got an A in front of both, okay? And here I've got an X up front and a Y up front. On all the ellipses, we had X and then Y, okay? And we just looked to determine which one had a larger denominator. But here, whichever one is listed first, just call them like the king of all of it, okay? So if the X is listed first, then all the major stuff is going to be horizontal. Okay, your transverse axis is horizontal, your focal points are horizontal, your vertices are horizontal. Okay, the only thing that's going to be not horizontal would be these two little points. Okay, the points that don't even have names anymore. This one, okay, Y comes first, so everything that's important will go in the vertical direction. Okay, so you'll go, your vertices will be up and down, your focal points will be up and your foci, sorry. The foci will be up and down. The graph will open up and down, okay? So this thing depicts everything. This little bitty b over here is only going to be the outsides of the box, okay? The less important part doesn't even have a name. So that's how you determine what direction and things like that is by what is listed first. That's super important because that's going to make or break you on this test. The ellipse, what matters is which one has the largest denominator. And with the hyperbola, all that matters is what comes first. Okay, and we'll see that when we start doing them. So now the rest of this stuff, the equation of the hyperbola is always equal to 1, just like the ellipse. Okay, it's got the subtraction sign. We just talked about that. A squared is always first. Notice that A is always listed first. A is our most important one because A goes with my vertices. Okay, so A is always going to come first on this one. C squared is now A squared plus B squared. Okay, so on the ellipse, we have a plus here but a minus here, and on the hyperbola, I have a minus here and a plus here. So that's kind of how I've always remembered it, is that they're just opposites of each other. Okay, if the hyperbola has a minus in between, then it's got a plus for the C, and if there's a plus in between, there's a minus for the C. Okay, they're just opposite. Now the asymptotes, okay, you should have seen asymptotes before. Actually, I know you have because you've done conics before, but if you forget, the asymptotes are boundaries. Okay, they are boundaries, and it means just that. That means I have to stay inside them. In fact, we aren't even going to touch them. We're going to think of them as like an electrical boundary. Okay, it's an electric fence. You can't touch them. Okay, so they're the diagonal lines. Okay, they go through the corners of my box and through the center, which is where they intersect, is right through the center of our entire graph here. Okay, so that is the asymptotes. We're going to get really close to our asymptotes without ever actually touching them. In fact, the asymptotes are only there so that they can tell us how skinny or fat our hyperbola is actually supposed to be. Okay, so there's got to be something that guides this direction. So that's what they're there for, and we will use them, and I will show you how to make them nice and pretty so that you don't lose points, because we don't want you to lose points. Okay, so I have to be able to write equations for those, which we should be able to do because that's just a straight line. If you ignore everything else on here, it's just a straight line. This particular one goes through 0, 0. Okay, so the slope can be found using rise over run. Just because we're looking at conics doesn't make this run, not Russ. Okay, just because we're looking at conics doesn't make it any different. Okay, we've always done rise over run for slope, and we're still going to do rise over run. Okay, and the equation of the line is y minus k is plus or minus the slope times x minus h. Now this should look very, very familiar because we've done this in the past, only we used, and you don't have to write this down, we use plus or minus m times x minus x1. Okay, and we use this when we did parallel and perpendicular lines and things of that nature, where I plugged in a point for the y1, x1, and that was my equation, along with the slope. Okay, we're doing the exact same thing, only I have a very specific point, which I'm going to use, which is the hk, which is my center. Okay, center is hk in all of my conics, so that's the point that I'm going to plug in along with my slope. And we'll talk about the slope here in a little bit. Alright, so let's take a look at the first one. So if I want to do this, I find all of my information exactly the same way that I have been. So for all of my ellipses, okay, if I want to find the center, I find what's added to x, which is nothing, and I find what's added to y, which is nothing, and that's my center. Okay, my direction is all about what's first, so it's an x first, so that makes it horizontal. And we're going to make a little note for yourselves because x is first. Okay, in this particular case, the denominator happens to be bigger there as well, but we don't really care about that. It's all because x is first. That's why it is horizontal. And my a value is always first, so the square root of 49 is 7. Square root of 36 is 6. Now when I go to find c, we're going to add instead, so 49 plus 36, which is c squared, is 85, which makes c 9.2. Okay, now if I want to find the vertices and stuff like that, you turn to your graph. So we're going to plot 0, 0. These three things always go together. The direction, the a, and the vertices. The direction, the a, and the vertices. No matter which conic you're looking at, direction, a, and vertices go together. So it's horizontal, which means I'm going to move horizontally 7 units to find my vertices. So I'm going to go right 7, plot that point. I'm going to go left 7, plot that point. Those are my vertices. Okay, those are my vertices. So write down the points for those. So that's going to be 7, 0 is this one, and negative 7, 0 is this one. And I'm literally just writing down the coordinates of those 2 points. Okay, I'm going to skip this for just a second. I can do the foci though. So it's going to be c, the distance from center to the foci is the c value. So if I go, and it's going to go in the same direction as my graph. So it's going to go horizontally 9.2. Okay, so 9.2 and 9.2. Again, the only thing that's even going to go the other direction is b. Same thing with the ellipse. The only thing that's not going to go in the same direction as the graph itself will be that b value. Okay, so my focal points, let's write those down. This one is at 9.20, and this one is at negative 9.20. Now, from there, the equation of the asymptotes. I'm going to go ahead and finish graphing first. So to complete my box, I need to do my b value. So I'm going to go up 6, and I'm going to go down 6. And I plot those points. Now, typically this is where I would make my ellipse. But instead of my ellipse, I'm going to make a dotted box. Okay, all the way around, dotted box. Okay, so there's my dotted box. Now the purpose of my dotted box is just to guide my asymptotes. Okay, it's just so that I can draw my asymptotes in there properly. So now you're going to go through the corners and through the center. I'm actually going to use my little ID here because it'll make it easier and faster. Okay, so I'm going to go through the corners and through the center. So here we go, and it's going to be a dotted line. Dotted line through the corners, through the center. There is my dotted line. Okay, do the same thing the other direction. Through the center, through the corners. Notice that I'm using my entire graph. Okay, don't give me tiny little itty bitty graphs. Okay, even if my box is only this big, I want you to use these graphs. That's super important that you use these graphs. Okay, I don't want to see tiny little, like, I stop right here. Okay, I don't want you to stop right here when you get outside your box. I want you to continue it on, make them pretty, okay, make them accurate. This is a graphing unit. We are graphing conics, so it's super important that you are accurate with your graphs. Okay, now the equation of the asymptote. I can go ahead and do that before I finish doing the rest of that graph. Okay, so for the equation, okay, I have a formula. So I need h and k, which I already have. Okay, here's my h and k. Oops, can't see it. There we go. Here's my h and k. It's my center. Okay, so I've got 0 and 0. So I get y. And I'm going to write it down here because I'm going to do the simplified version here. Y minus 0 is equal to plus or minus, oh, don't have my m yet, but I have my x minus 0. Notice that I'm leaving y and x in there. I'm trying to write an equation. Equations need y's and x's in there. Okay, that's kind of the point. We got to have that y and that x in there. So what I need now is my slope. Okay, well, slope is very easy to find. Okay, it is rise over run. So go back to your graph. That's why we went ahead and graphed first. I know it goes through the corner, okay, and it doesn't matter which corner. I'm going to count rise over run, so go up, okay. Well, I know I went up 6 units because that's what my b value was. So I went up 6 units, so it's going to be 6 over, and I went over 7 units to get to that, okay. So 6 over 7, up 6 over 7. It will always be your A and B values. You just have to figure out whether A is on top or A is on bottom. Okay, because that's going to switch sometimes. But it will always be either, and you might want to write that down, that it's either plus and minus A over B or plus and minus B over A. And in fact, it's B over A when it's horizontal, okay, and it's A over B when it's vertical. So if you want to make that little note, it might help you. I didn't even write it so you could see it. But vertically, it's plus or minus A over B, and horizontally, it's plus or minus B over A. Okay, but if you can't remember those, because those are not on your card, you can always just count from center to the corner. You count rise over run. So up 6 over 7. Okay, so that's my slope. So that's what goes in here. So plus or minus 6/7. By the way, the plus and minus, I get the minus because here we have 2 asymptotes. One is positive and one is negative slope. So that's why we get the plus and minus. That takes care of the equations for both asymptotes at the same time. Okay, so now here, those zeros can really just go away. So you get y is equal to plus or minus 6/7 x. Okay, the x comes from right here because I would distribute that 6/7. So that's the equation of my asymptote. So when they ask you for an asymptote, this is what they want. They want the equation of that asymptote. Okay, so the very last step of this hyperbola is to actually draw the hyperbola itself. All of this is just guidelines so that you can draw a hyperbola. So drawing the hyperbola, okay, this is a horizontal hyperbola, so it's going to open left and right. Okay, it's going to touch your vertex, and that's super important because this is what I'm going to look for when you go to take your test. Okay, it needs to touch your vertex, and then it needs to get close to the boundary without touching it. And if you draw arrows and the arrow touches it, that's fine. I'm not going to take off points for that. But that's what it should look like. It needs to come over here and get close to my boundary, okay, to my asymptote without touching it. And that's what we're looking for. Touch here. This is the vertex. Okay, touch the vertex and only the vertex. It shouldn't touch anything else. And there you go. So that's how you draw a hyperbola. Okay, so there's another one on there. Okay, so that second one, what you're looking at is I'm not equal to 1. So I can't do anything with it yet. So we're going to divide by 16 first. Okay, divide by 16. So I've got y plus 3 squared over 4, right? Because 4 over 16 reduces to 1 over 4. And then minus x minus 1 squared over 16. There's nothing to reduce with, and that's all just equal to 1. Okay, so here we go again. I'm already set up, ready to go. Okay, my center. Now be very careful here. Y is listed first now. With the hyperbolas, it's not always just x, y, x, y, x, y. It's switched. So when I get my x value for my center, I need to get it from the x. So change the sign, I get positive 1. And then change the sign, I get negative 3. So be very careful with the hyperbolas that you do your center correctly. Okay, the x value should come from the x portion, and the y value should come from the y portion. Okay, so now direction. Y is first, that makes it vertical. Okay, a is always first, so the square root of 4 is 2. It does not matter which one is bigger. That's an ellipse. We're not on ellipses anymore. We're on hyperbolas, and it's all about what's first. Okay, so this is the master of all of it. Okay, so here is my direction is vertical. My a value is 2. Okay, and we'll get the vertices in just a second. B value is going to be the 4. C value we're going to add together, so you get 16 plus 4. C squared is equal to 16 plus 4, which is 20. So C is going to be 4.5. Okay, when you square root 20, you get 4.5. Now the vertices, let's go to our graph. So when x is 1, y is negative 3, plot that point. Okay, when x is 1, y is negative 3. Let me see if I can get a color in here. You might actually be able to see. Maybe. Okay, so when x is 1, y is negative 3. Is that any better? No, none whatsoever. Let's try a different color. You can at least, that one's at least a little darker. The pencil kind of reflects light, and so it kind of gets hard to see on the screen. I don't know if you can see it better on the video, but it's hard to see on the screen. So, okay, so I've got my point, and then I've got the, make sure it doesn't go through, that would be bad. Okay, so I've got my center point, and now I'm going to go vertically 2 units to get my vertices. Remember, these 3 things go together. It does not matter whatsoever which one is bigger or smaller or anything. This is all first, so this is what drives everything. This is the king. So we're going to go vertically 2 units. So up 2 units and down 2 units. Okay, up 2 units and down 2 units. Let's go back to the marker. Up 2 units and down 2 units. Okay, plot those points. Now I also am going to go, let's go ahead and write those vertices down. So up 2 units and down 2 units. So here we have x is 1, negative 1. And here I have x is 1, negative 5. I have no idea what I just wrote. I just wrote a negative. 1, negative 5. Okay, so 1, negative 5 is going to be my 2 vertices. Now I can also go ahead and graph my foci while I'm here. So I'm going to go from center. I'm going to go up again because this is all driven by that vertical, by which one is listed first. So we're going to go up 4.5. We're going to go down 4.5. Okay, and those are my foci. Those are my foci. Okay, so now I'm there, so I can write down my focal points, which are going to be when x is 1, y is 1.5, and when x is 1, y is, that's negative 7.5. 1, 2, 3, 4, 5, 6, 7.5. So negative 7.5. I also could have just, I'm doing vertical, so I can add 4.5 to negative 3, which gives me 1.5, and I can subtract it to get negative 7.5. So, again, you can always do these things mathematically. I've come to find that most people are doing them graphically, so I figured I'd just kind of go with it. Alright, so slope of the asymptote. First I need to finish graphing this thing, so we're going to go right 4 and left 4 from the center. 1, 2, 3, 4. Remember, everything's always about the center. We're always going from the center of the graph itself. Not the center of this. That's only if the 0, 0 is the center. Okay, we're always working off the center. So, let's graph our little dotted box. So I want to note something here, and it might help you understand things a little bit better. I have a wide box, and yet it's vertical. Okay, that's fine. It doesn't have to be, because remember, the size doesn't matter anymore. It's all about which one is first. So that doesn't matter whether it is wide. It can be wide and vertical. It can be tall and skinny and still be horizontal, which we'll see in a little bit as well. Okay, so now I'm going to do my asymptotes. Okay, through the center and through those corners. Pencil's not very sharp anymore, so I'm going to leave myself a little room for my pencil. Okay, so there's one direction, not the band either, but actually just one direction, and here's another direction. sure half of you are probably going, who's One Direction? And that's okay. I know it because my niece. And I'm sticking to that. Alright. Now, I have everything in place. Okay, you should have a box that looks like this. It is wide, and that's okay, even though it's a vertical graph. The slope of this asymptote. Okay, the slope went up 2 and right 4. You can literally count it. Okay, the slope is up 2, right 4. Okay, rise over run. 1, 2, 1, 2, 3, 4. Okay, you can literally count from center to the corner. And it doesn't matter what corner, because if I come over here, I'm going to go down 2, right 4. Well, that's negative 2/4. Okay, if I go this way, it would be up 2, left 4. That's negative 2/4. And if I went to this corner, I'd get down 2, left 4, which is negative 2 over negative 4, which becomes back to positive 2/4. So it's all the same. It doesn't matter which corners you go to. Great thing about conics, they're very, very symmetric. That's why I love them. Alright, so here, they didn't ask for an equation this time. They just wanted the slope, so that's all I'm going to write down. I'm not going to take the extra steps and plug it in. I am going to reduce, though. 2/4 becomes 1/2. And that's it. Okay, so slope is equal to plus or minus 1/2, and that's all I need. Now I just need to finish off the last little bit of graph, okay, which is to do the actual hyperbola, because I haven't done the actual graph yet. So, from the vertex, it's going to swing way out wide, get really close to this thing without ever touching, and it just gets closer and closer. Okay, and they don't have to be super, super, super perfect. Like right here, I kind of ventured up a little bit. It shouldn't actually do that. It should actually continue to get closer, but I'm not going to like kill you on stuff like that, as long as you're using the full graph and you're going out to those boundaries. Now, let me warn you, if you give me this, that I will take off points for. Okay, if you just kind of touch and you go, yep, that's it, that's my graph, that does not work. Okay, we spent all this time to make this super pretty little box, so that we knew where our asymptotes were going, so that we knew how wide this thing was really supposed to be, and that's what I want to see you do. Okay, so I want to see you get close to those boundaries without actually touching, okay, and that's what I'm going to be looking for. That's what your graph should look like, okay. Again, not going to be super perfect, and I'm okay with that. Everybody's is going to look just a tiny, tiny bit different. Okay, because I could have gone a little wider and ended up here. I could have gone in really tight and come in closer. Okay, and that's fine. I'm not gonna. Again, we're not doing exact points here. Okay, but you do need to be kind of close. All right. I would suggest that you hit the pause button and you do number 3 and number 4, because you should be able to do both of those at this point. Okay, I would highly suggest you try them. See if you're getting the same thing. See if you're understanding direction and your A's, your B's, your C's. Okay, if you still don't understand, watch me do it and then go back and pause it and see if you can do it. So if you're struggling, I would say don't even write this down yet. Just watch it, and then after you've watched it, go back and see if you can do it. It's another way that you can go about it. All right. So starting with the fact that I do not have this thing equal to 1, so I'm going to divide everything by 4. So 4 over 4 gives me x squared. Now 4 over 4 is 1, so I'm going to go ahead and put a 1 down there because, well, we're doing conics and I want a fraction, so I'm going to go ahead and put a 1 underneath. I also have y squared over 4, and that's all equal to 1. So the center here is going to be at 0, 0, because nothing's added to x, nothing's added to y. Okay, the direction, x is first, so that makes this a horizontal graph. A is always first on the hyperbola, so the square root of 1 is 1, the square root of 4 is 2, and C is going to be 1 plus 4, which is 5, and the square root of 5 is going to be 2.2. Okay, so now let's go ahead and graph from 0, 0. There's 1 point. Oops, helps if you can see it. Okay, we've got 0, 0 here in the center. Okay, we've got 0, 0 there in the center. Now I also have, so it's horizontal, which means I'm going to go left and right to get my vertices. So I'm going to go right 1 and left 1. And there are my 2 vertices. Okay, so that I can go ahead and write down. So I've got negative 1, 0, and positive 1, 0. And that's, again, just writing down those actual coordinates. This is sitting at 1, 0, and negative 1, 0. Okay, I can go ahead and do my foci as well. Sorry, I got a cough. I can do my foci as well, so I need to go 2.2 units, the same direction. So we're going to go right 2.2, and I'm going to go left 2.2, and I'm going to drop those focal points right there. Okay, so now I've got the focal points, which I can go ahead and write down, negative 2.20 and positive 2.20. Okay, hasn't gone vertically at all, still sitting on that axis. Now, I need to finish graphing, if you give me a second, because my screen went away yet again. That's how you can tell it's a long unit, or a long lesson when it starts going away. Alright, so I can go up 2 units, down 2 units. Okay, so here's another good case, like I was talking about before. When I draw this box, it is tiny, first of all, but it is taller, okay, than it is wide, but it's still going to be a horizontal graph. It's still going to open up left and right. Okay, so let's go ahead and draw my asymptotes. Okay, and I'm going to have to turn the paper here for a second. So I'm going to draw through the corner boxes, through the center. Okay, it's a little harder when they get this small, but they're still doable. And you can still be very accurate with it. And I expect you to be very accurate with it. Okay, so there's one direction. And again, I really suggest that you actually use a straight edge of some sort. It makes this a lot easier. Because if you're trying to eyeball this and make perfect straight lines, especially on something this small, you're going to end up, you could potentially end up with lines that are just a little bit off, and this thing's not going to look symmetric the way it's supposed to. So I would suggest getting a straight edge. You should all have your IDs on at school, which means you should all own IDs at home, which means that you should be able to use that. That's what I'm using. Okay, so the equation of the asymptote, let's go ahead and do that. So my slope here, we have to have the plus and minus to account for both of them. And then we went up 2 over 1. So 2 over 1 is just 2. Okay, again, count from center up 2, right 1. Alright, so now that's my slope, but I got to put it in. So y minus, this is my h and my k. Y minus 0 is plus or minus 2 times x minus 0. So the zeros just go away. We get y is equal to plus or minus 2x. Okay, y is equal to plus or minus 2x. I hope you got that. Okay, and the very last step is to just graph the actual hyperbola. Okay, so we're going to go both directions. Over there and over there. Okay, so there is my hyperbola. Okay, there is my hyperbola. Alright, so that was 3. Now let's look at 4. Okay, 4 is already ready to go. It's equal to 1. We're fantastic. We've got nothing in front of the x and the y, so we're just going to go. So x here is 4, y here is negative 2. Okay, our direction is still horizontal because x is first. A is the square root of 49, which is 7. B is the square root of 25, which is 5. C squared is 49 plus 25, which is going to be 74, which makes C 8.6. Okay, so here we go. Let's graph. When x is 4, y is negative 2, that's what's great about these things, is once you have those, like 4 different things, then you're ready to graph. Okay, so 4, negative 2. It is a horizontal graph, which means that I'm going 7 left and right to get my vertices. So 7 left gets me right here, which is at negative 3, negative 2, rather. Okay, negative 3, negative 2. And we go 7 right, which is unfortunately going to take us just off this little graph to 11, negative 2. Okay, and I know that because when I do 4 plus 7, I get 11, so it's just off. Okay, so I can also do my focal point. So I'm going to go left 8.6 from here. So that was 7, 8.6 is right here-ish. Okay, here we've got 11, 12.6 or 7, 8.6, so that's going to be here-ish. Okay, so when I write down the focal points, well, this one is pretty easy. We got 3, 4, negative 4.6. Okay, which should be pretty easy because from the center, I subtract 8.6, I get negative 4.6, and it's still a negative 2. And then if I do 4 plus 8.6, I get 12.6, negative 2, which is where this little guy is, way out here. It's not even on the screen. There we go. Okay, so this little guy way out here. And we're just guesstimating because I am off my little graph here, which is fine, okay? You're just going to kind of come close. Here's my 10. Here's my 11. Okay, here's my 12.6-ish. Okay, that really should be more like 11, and then 12, and then 0.6-ish. So, that's where I'm sitting. In order to do the slope of the asymptotes, I need to finish this thing off, so we're going to go up 5 and down 5. I'm going to make my box. I like the box. Box makes my life easier, makes things ever pretty. I will be expecting you to make the box on the test, so keep that in mind. Okay, please don't think, oh, I can draw all that without that. Okay, I'm going to expect to see the box when you take your test. Okay, because I want to see that your asymptotes are accurate. Yes, we can technically check it just by looking at the slope, but I just like to see it, and it should be done this way, so that's how we're going to do it. Okay, so through there, there is that one, and then the other direction. Okay, so through the other direction. And then do your, we can go ahead and do the slope of the asymptotes. Okay, find the slope of the asymptote. So we went up 5, 1, 2, 3, 4, 5, and we went over 7. 1, 2, 3, 4, 5, 6, 7. So plus and minus 5 over 7. And they only asked for the slope this time. We didn't even have to do the equation, which is nice. So up 5 over 7, and then put your actual hyperbola in there. Okay, this one's not quite as fat as all the other ones. Kind of gets there a little slower. I apparently cannot talk and graph at the same time because I get quiet every time I try to make hyperbolas. Because I'm trying to make them very pretty, so I'm trying to focus so that they look nice so that you can see what I want from you. Okay. Now, you have to be able to take information as well and actually create equations from information. These should be pretty quick, though. So start with the center at 0, 0. Okay, so start with the center at 0, 0. So honestly, when I go to write my equation, I'm going to do it all together. So that tells me I've got x squared and y squared. Actually, I take that back. We're not going to do that because there's something else that has to happen. We're just going to plot our points. So I got 0, 0. Vertex is 4, 0. And the other one is negative 4, 0. Okay, so we've got 4, 0 and negative 4, 0. Well, those are my vertex points. Okay, well, the vertex always goes with A, so that means A is 4, because the distance from from the center to the vertex is the A value, so that's 4. Okay, they also tell us that the focus is at 10, 0, and negative 10, 0, which is out there. Okay, well, that tells me my C value, because the distance from the center to the focus is your C, so that's 10. That also tells me the most important information that I need. Well, not the most, but it is super important. The focus is lying horizontally with my vertex, which makes this a horizontal graph. And that will matter when we write our equation. Okay? This has to be a horizontal graph because the focal points are horizontal. And so are the vertices. The vertices okay, are these points right here. So they tell me that this thing has to be horizontal. All right, and then to find b, you use the same formula. We're just going to use a little different. So a squared plus b squared. Plug in your c, so I get 100 is equal to 16 plus b squared, which makes b squared equal to 84, which makes b approximately 9.2. Okay, so that makes that approximately 9.2. So we've got all of our information that we need to write the equation of the hyperbola. Okay, so the hyperbola here, the reason why I said I didn't want to start yet is because first I had to figure out whether it's horizontal or vertical. Since it's horizontal, that means x goes first. If this was a vertical graph, then y would go first. Okay, but since it is, let me write it in my spot here. Okay, so since it is horizontal, x goes first. I have nothing added to the x, so it's just x squared. A is always first, so this is just a. Remember, the formula is a squared, so square it, you get 16. It is a hyperbola, so it's got to be a minus sign in between. Okay, and then we've got the y. Again, there's nothing added to y, so it's just y squared. And 9.2 squared. Now, don't do 9.2 squared in your calculator. We already know b squared is 84. Okay, before we actually did the rounded version, we had the full version. So b squared is 84, and hyperbolas are always equal to 1. So that's my equation. That's simple as that. Okay, so now we've got to go up 9.2 and down 9.2 and make our little dotted graph, our dotted box, which is just over 9 here, which is what I'm trying to show, is that it's just over 9 and just below negative 9. So to come all the way down just below the negative 9. Okay, it shouldn't be at 9. It should be just below it and just below it, above it. Alright, so there are those. So my slope of my asymptote, which is going to go through those corners, this is going to be a really interesting looking graph. Okay, because it's mostly off our charts here, but we're still going to do it anyways. We're going to go through the center and through the corners. To grandmother's house we go with our cute little dotted line. Okay, and do that both directions. Again with the silence. I have no jokes. I have nothing. I'm just making graphs because I enjoy it. Okay, so now I have this. I've got everything I need. I can graph from there. Okay, the equation of the asymptote. So my slope here, I went up. The slope is up 9.2 units, and it went right the 4 units. Okay, and again, I'm going to have y minus 0 is plus or minus 9.2 over 4 times x minus 0. If your center is 0, 0, you don't have to show me this step where you put zeros in and then they disappear. Okay, if you know that they're going to disappear because they're 0, 0, you do not have to show me that step. You can kind of skip that step. Now, if it's anything besides 0, 0, you can't skip it because you've got to solve that thing. Okay, because you've got to solve it for y. But if it is from 0, 0, then I am perfectly okay with you skipping that one particular step. So the very last thing is you need to actually graph this thing, which is super fat and wide, and it comes way over here. Okay, and this thing would actually go way out. So you should see a big bow looking thing. So it reminds me of all the time when I do this one. Okay, when I do ones like this anyways, they remind me of bows. Okay? Alright. Last one, and then we are done with hyperbolas. Very last one. Here we go. So I have a graph. They just want me to identify stuff and write an equation. That's fantastic. It's easy. Keep in mind that these things were supposed to be perfect. They're a little bit off. Okay, the little box is a little off, but they were supposed to be perfectly on there. So please keep that in mind when you're looking at your notes here. The center goes through 0, 0. Okay, the vertices. Now it's easy to tell which one are the vertices because they should be the tips of the actual graphs. Okay, notice I don't have any hyperbolas over here or over here. They're only up here and here. That makes this thing vertical. Okay, because they line up vertically. So my vertices lie here and here, which is at when x is 0, y is 3, and when x is 0, y is -3, is where those are supposed to be at. So those are my two vertices. Now that makes my a value 1, 2, 3. Because the a value is the distance from center to my vertex. So up 3 units. Okay, so that makes this other little nonchalant, that's not the word I'm looking for. Less important. We'll go with less important because I can't think of a better word. Your b value. So we went over 1 for b. Okay, so to find c, be careful. Make sure you square. It's a squared plus b squared. So that makes it 9 plus 1, which is 10. So the square root of 10, which is 3.2. So c is equal to the square root of 10, which is 3.2. Okay, so that's what we've got there. Now the foci, they didn't give me the foci on here, so I have to actually find them. So they're going to go the same direction as my vertex, because they should be inside my hyperbola. So we're going to go to 3.2, which is just outside that box. Just outside that box and right inside those things. So we get 0, 3.2, and 0, -3.2. Okay, so now we can do the equation of the hyperbola. Okay, y comes first, which means it's vertical, which means y has to come first. So we've got y squared, okay, nothing added to y, over a is always first. So 3 squared is 9. It's minus x squared over 1 squared is 1, and that's equal to 1. Okay, and then the equation of the asymptote, well, I know the slope is up 3 over 1, so it's just 3 over 1, it's just 3. So again, I'm going to go ahead and skip this time that putting in the zeros, because the zeros disappear. So I get plus and minus 3x. Ooh, on the last problem, I just noticed we missed putting the x on there. That x should have been there. Super sorry, because when I distributed here 9.2 over 4 times x, I should have still had an x. Anytime they have an equation, I should have a y and an x. If it's just slope, I just need the number. Okay, so going back to the first one, I got a y and an x because it was an equation, y and an x for the equation, y and an x for the equation. So that is the end of asymptotes.